Good morning. You are watching the 35th segment on my Cosmology series of talks. My subject today is solar eruption. Solar flares, you must have heard about that name very often in the media, or coronal mass ejections, high-speed solar wind, and solar energetic particles are all forms of solar activity. All solar activity is driven by the solar magnetic field. A solar flare is an intense burst of radiation coming from the release of magnetic energy associated with sunspots. Flares are our solar system's largest explosive events. They are seen as bright areas on the sun, and they can last from minutes to hours. We typically see a solar flare by the photons or the light it releases at most every wavelength of the spectrum. The primary waves we monitor flares are in X-rays and optical light. Flares are also sites where particles like electrons, protons, and heavier particles are accelerated. A solar prominence, also known as a filament, when viewed against the solar disk. So prominence is a large, bright feature extending outward from the sun's surface. Prominences are anchored to the sun's surface in the photosphere and extend outwards into the sun's hot outer atmosphere called the corona. A prominence forms over time scales of about a day, and stable prominences may persist in the corona for several months, looping hundreds of thousands of miles into space. Scientists are still researching how and why prominences are formed. The red glowing looped material is plasma, a hot gas comprised of electrically charged hydrogen and helium. The prominence plasma flows along a tangled and twisted structure of magnetic fields generated by the sun's internal dynamo. An erupting prominence occurs when such a structure becomes unstable and bursts outward, releasing the plasma. The outer solar atmosphere, the corona, is structured by strong magnetic fields. Where these fields are closed, often above sunspot groups, the confined solar atmosphere can suddenly and violently release bubbles of gas and magnetic fields called coronal mass ejections. The abbreviation is CME. That is coronal mass ejections. A large CME can contain 1 billion tons of matter that can be accelerated to several million miles per hour in a spectacular explosion. Solar material streams out through the interplanetary medium, impacting any planet or spacecraft in its path. CMEs are sometimes associated with flares but can occur independently. So I have a nice video for you on solar eruption. They are also known as protuberances. So I'm going to run that animation video for you.
Gas eruptions on the surface of the sun can reach a height of several 100,000 kilometers. These phenomena are called protuberances and often result in solar material being hurled far out into space.